Okay, so this is the last of the videos looking at the amines and amides, and it's just looking at a small section looking at the amide functional group. Okay, so we're on page 9 of your notes and we're just looking at this amide functional group. So here it is, you've got the C double bond O and you've got that NH2 group. If it's an N substituted amide, one of those hydrogens on the nitrogen has been substituted for an R group, but this is just, if you like, a subset of the amide functional group. Naming them, very straightforward. Eth gives me the number of carbons in the chain, and then I stick just amide on the end of it. So I have ethan amide. So this would be 2 carbons, double bond on the second carbon, and then I'd have my NH2 group there. I'd have hydrogens on that one. So that's my displayed formula, and I'd have CH3CONH2 as my structural formula. So there we have propan amide. So we have 3 carbons, and then we have our functional group. N-methyl ethan amide is an example of an N substituted amide. So I have a methyl group substituted onto the nitrogen, then I have my ethan amide. So there's my ethan, and the amide is here, and I've got that methyl group replacing one of the hydrogens. The last one we need to be aware of is benzamide, which is a benzene ring with an amide functional group on it. So the amides generally have quite high melting and boiling points. The reason for this is they usually have a high molecular weight, so they've got strong London forces, but they can also do hydrogen bonding. So as well as London forces, you have hydrogen bonding. And that's because, again, if you look at the functional group, you have the nitrogen, you've got the delta positive hydrogens, and we've got the lone pair on the nitrogen. We've also got this functional group here, this C double bond O. The oxygen also has lone pairs on it, so also can do both permanent dipole, and hydrogen bonding. So they're all soluble in water, so they have high solubility due to hydrogen bonding. Obviously, as with all organic functional groups, the longer this R chain becomes, the weaker the hydrogen bonding and the less soluble they become. In terms of bond angles, we're interested in the bond angle around this carbon, and this is a planar functional group because you've got 3 areas of electron density. So you've got a bond angle of 120 because you've got 3 areas of electron density, as you've got 3 sigma bonds around that carbon, and those bonding pairs of electrons will separate out to maximize separation, minimize repulsion. Now, one thing you do have to be aware of is this molecule, or these amides, are not basic. They are actually neutral. And the reason for that is that this lone pair here on the nitrogen is firstly spread out amongst this group, so we delocalize it over the carbon and the oxygen, makes it much less available. Also, if this hydrogen here, this nitrogen here, was to accept a hydrogen, it would be adjacent to this carbon, and this carbon is already very delta positive, so trying to put a positive next to a delta positive is very difficult, so they're less basic than you would expect. Okay, so we can prepare one of these by reacting ethanol chloride with ammonia to make the amides. If I then react ethanol chloride with an amine, I will get the N substituted amide. Okay, so this reaction here, we produce our ethan amide. So I've got my CH3 group, my C double bond O, and then I've got my NH2 group, and I've got HCl as my separate product. Again, you probably get a copious amount of white smoke because this HCl reacts very rapidly with any excess ammonia to make ammonium chloride. Okay, so there we have our 3 reactions, and they're an example of what we call a nucleophilic addition followed by elimination reaction. So it's in 2 steps. So the first step would be nucleophilic addition, and the second step is an elimination reaction. So here with ammonia we just get the amide. With the amine we get an N-substituted amide. We can also do this with aromatic amines to make an aromatic amide, and this is a particularly important reaction because we've got ethanol chloride reacting with 4-aminophenol to make N4-hydroxyphenyl ethan amide. That is better known as paracetamol. So that was just a short little video today looking at the amides and their reactions. They're quite straightforward as they all react in a very similar manner. So you just need to learn how to name them and those couple of reactions that we've looked at. So until the next topic, take care. Bye bye.